22-minute webinar, Designing for the Internet of Things. My name is Alex Savell, and I'll be your host for today. So let's get started and jump right in. We have a lot to cover in 22 minutes. For those of you on Twitter, we encourage you to talk about today's webinar as we proceed, and you can do that by using the hashtag SWIOTwebinar. Just a couple of quick items I want to point out to you before we get started. First, in GoToWebinar, please notice that the full screen button to move in and out of the full screen mode, we suggest using the full screen mode. If you have questions during the presentation, you can enter them in the questions section, not the chat section. We will be answering questions at the end of the webinar. Also, we will have a few poll questions throughout the presentation to keep it very interactive, and we ask you to answer these with very quickly so we can keep within our time frame, and I'll be letting everyone know and share the results as we go. And please note that you'll be able to download a recording of the webinar after today's presentation. So let's get started with our first poll question. Is your company involved with connected devices? You can start by answering that and give you a couple of seconds. All right, I'm going to close it out, share. So we've got about 68% of you said yes, you are involved with connected devices. That's great. All right, we'll move on. Today, and with that, I want to introduce to you our rock stars for today, presenters. With us today, we have Lois Feinstein and Rafael Raimondo, both who are senior SolidWorks product portfolio managers. Louis is responsible for our electronic solutions, while Rafael is responsible for our new solutions. And with that, I'd like to turn it over to Rafael.
Hello everyone. Thank you for joining this webinar on designing for the Internet of Things. In this session, we will cover what is exactly the Internet of Things, what does it mean, then how to design this kind of devices, smart object or connected object, then what is the current workflow and for the Internet of Things design, then we'll see where SolidWorks solution sits in this workflow, and we'll give you an overview of the portfolio of solutions of SolidWorks that will enter the IoT design workflow. And then, as Alison mentioned, we'll finish with some Q&As. So to start, what is the Internet of Things? So basically, Internet of Things is a system of smart and connected objects where they communicate together, and you can have access to them through the web. And a smart object carries application logic that enable the device to be aware, to have a sense of its environment, capture information, and then interact with the environment and give back the information to the user, and with either interpretation or just analytics on top of this environment information. Then designing a smart or connected object, you need to consider, in fact, three phases of design. We have the design for the device itself, what we will call the engineering design. Then for the web application, where you will gather all the information captured by the device, we call obviously this the web device, the web design portion, and then the apps, as any connected device needs to be connected, and you need to have the information anytime, anywhere, so on any mobile devices, tablets, and smartphones. Two famous and well-known examples of Internet of Things are smart and connected devices. The first one is Fitbit, so it's a health and fitness tracking device. They have also the body scale and the remote control mechanism of them through mobile apps. Obviously, you can also follow and dashboard all the information captured by these devices, by the Fitbit devices, directly on the web. The other well-known is Nest, which is a very smart object with two products right now. So the Nest Protect, which is a smoke carbon monoxide detector, connected to your Wi-Fi network, and as well as connected to the Nest thermostat to manage the energy efficiency of your house. And both of them are controlled either using a mobile device or an app, or directly using a web browser on your laptop or a desktop computer. So if we go in a little bit in detail of designing for an IoT and IoT ecosystem, so we have these three design silos: for engineering, web, and apps. And SolidWorks, obviously, we're focusing on the engineering design vertical, which is done by all the CAD and electrical and electronics tools we provide. And who is doing that? Usually I have the mechanical engineers, the electrical engineers, and an industrial designer. And how you do that using SolidWorks solutions. If we go deeper into an anatomy on an IoT device, so let's take the example of the Nest. The Nest is composed of mechanical and electrical and electronics parts, like the display, the ring that embed all the circuit boards, chipset, RAM, memory, and also all the plastic parts, as well as the power management system, so in case it's wired and battery, and all the communication chipsets, as well as all the advanced sensors, like in the case of the Nest, the motion detection, the temperature and humidity of the environment where it's installed. And you can also control, obviously, with the mobile application, and plan scheduling, plan set up the behavior of the IoT device, of the Nest in this case. So what are the, basically a smart device or a connected device is a concentrate of technologies. And what are these key enabling technologies? Obviously, we have the technology of convergence between electrical, electronics, and mechanical system. We have now new advanced human interface, such as advanced LCD display with motion capture that switch on and switch off the device. We have the system on a chip, so let's say the microprocessor, or all the sensors and communication technologies. We have also the so power management with now inductive or kinetic energy harvesting system. Obviously, all the sensors technology like RFID, OCR, localization, MEMS with gyroscope, sensor, motion sensor, and then all the communication layer with the integrated information system built into the device, and the near and far field communication technology.
All right. That brings us to our second poll question. Let me just bring that up for you and launch it so you can fill it out. Does your company develop IoT technology? Yes, no, or use commercial off-the-shelf? Can you fill that out? All right, we'll close that. Looks like everybody will close that out right now. Share that out. So it looks like 67% of you said no, and 21% of you said use off the shelf. That's great. We'll move right into continue with our presentation.
We've engaged with hundreds of companies and found that typical IoT design is completed using a serial process. The electrical design team will develop schematics and associated sub-assemblies as necessary for the project. Then the data is saved and thrown over the wall to the mechanical design team. The mechanical designers develop the project in SolidWorks 3D CAD, but have little knowledge about the physical requirements of the electrical aspects, such as EMI suppression, the required routing paths, any signal integrity rules that must be observed, or even the mass properties of the electrical components. Once the mechanical design is far enough along, in order to accurately integrate the electrical mechanical aspects into design, it typically requires building a non-functional mock-up or a physical prototype, then evaluating the subsystem interfaces manually. Many customers reported back to us that the ball of string and micrometers were the most prevalent tools used in the companies for this task. Finally, with accurate measurements in place, the documentation team can then complete the final drawings so they can create the first prototypes can be made. Assuming that everything is right at this stage, the project can progress to the operational planning phase, procurement, and finally into production. While this is a time-tested methodology, there are several drawbacks that need to be considered. Since we are not integrating the electrical and mechanical aspects early in the design phase, we are effectively limiting how quickly we can start production. And if we identify a problem during the integration, we are forced to make last-minute changes that can greatly impact the production start. We recently were with one of our customers who missed a project deadline simply due to poor communications between the electrical and mechanical teams. It was obviously totally preventable error that had technicians reworking their nearly finished project to accommodate preventable last-minute design changes. With the currently available SolidWorks portfolio of products, we tackle this fundamental process flaw by bringing all the designers of the project together in a real-time collaborative environment. This parallel approach offers the obvious advantage of shorter time to market, resulting in reduced development costs as well as significant competitive advantages, while achieving a cohesive design and downstream benefits of having all of the data fused. Another point worth making is that improved communications and collaboration we offer across multiple departments. The entire project team has the insight necessary to make better decisions about designs, sourcing the project, and planning well earlier in the design process.
All right, so that brings us to our third poll question. What is your company's readiness to deploy tools for IoT? You're in place, in development, investigating, or no plans at this time? Give you a couple of seconds to continue filling that out. All right, close it out and share it out. So it looks like about 52, over half of you, have no plans, while 35% of you are investigating. So that's good. All right, so we'll hide and continue on with presentation.
Well, right now we're going to take a look at a typical IoT system design workflow. The first thing we have is the ECAD, or the printed circuit board technology. We have the EDA to MCAD, or the interface, the EDA data exchange, where then we move on to the design and documentation of the 3D capabilities of the products. We do design simulation, the link to manufacturing, and finally the creation of technical communications and manufacturing documentation. And most of the time, most of the data needs to be under product data management control. Right now, we're going to take a look at the wide-ranging capabilities of SolidWorks technologies through the development of a web-enabled appliance, an everyday appliance. We're going to develop here, using our tools, a refrigerator that has various sensors and RFID capabilities, and with human interface capabilities that create a web-enabled appliance.
SolidWorks is an extremely powerful tool, enabling engineers and designers to realize their ideas in full 3D. In this case, however, we want to take an ordinary ice maker on this refrigerator and web-enable it. This is a lot more than just adding an LCD screen, however. There's a lot of electrical components that are going to need to support this system for RFID sensors found throughout the design. And SolidWorks is a great tool to do this. But where do we start? In SolidWorks Enterprise PDM, we can store all of our files in one central location. And with powerful search tools, it's quick and easy to find any design that we're looking for. In this case, we want to work on the smart display. Once it's open, where do we start? We're going to want to go ahead and take a look at this PCB board and get the information to the electrical engineers. CircuitWorks' built-in library connects with the 2D electrical engineers' data, meaning that anything we do in 3D can be brought over. We simply need to choose to export it to CircuitWorks and follow the guided wizard. In this case, we do need to tell it where the PCB board's main face is and find a few different things, such as do we want to select the outline or let SolidWorks generate it for us? Then we want to find our non-plated holes and our plated holes in our designs. And finally, we can specify any important areas such as keep-outs in our designs. Once this is done, it opens up inside of SolidWorks, where we can review everything that we've created in the 3D environment before we export it off to the ECAD tools. You can see that filters make it easy to evaluate our designs and make sure everything's right, and when we're ready, we simply choose to sync it with ECAD. We can even add a note letting the electrical engineer know what our design intent was. They'll be able to see all the information such as the plated and non-plated holes and make any adjustments as necessary. There might also be changes to the 3D model we need to make right inside of SolidWorks. For example, getting rid of an interference is quick and easy. But once all these changes are done, how do we relay them to the rest of our organization? Enterprise PDM again is built right in, and all we need to do is check this document in, and it immediately starts to go through a workflow. In this case, we've submitted it for approval, and we can see how it travels through the rest of our organization. Once a change is required, it goes into pending approval, and then an engineering manager needs to finally approve this design. Here we'll log out and log back in as somebody with an engineering manager's privileges. They get a notification that there's been a change. They can view the change with the eDrawings viewer quickly and easily, making sure that all the changes have been made properly. Finally, all that's left for them to do is choose Approve and add a note. Once this is done, this design is ready for manufacturing at this point. But there's a lot more that needs to be done in the refrigerator design. The electrical wiring harnesses that connect to everything need to be incorporated. And SolidWorks Electrical makes it easy to quickly find projects by simply searching for them, and then using powerful tools, we can simply drag and drop existing electrical schematic components into our designs and make changes to them. We can block out specific areas if they're going to be found in unique parts of our designs, and we can simply drag and drop other electrical components wherever they need to be added. Here we need to add a grounding wire, so we'll simply search the massive symbol library included with SolidWorks Electrical and simply drag and drop this out onto our electrical schematic. Once this is done, SolidWorks Electrical helps us lay all these components out in the 3D environment. Automatically generating the harness, we can go in and make any adjustments or tweaks and changes as necessary. We have the 2D electrical schematic, but for manufacturing we might want a pin board diagram to be used on the shop floor. Any electrical harness inside of SolidWorks can be flattened using annotative or manufacturing practices. In this case, we chose manufacturing. We can always return to the full electrical harness at any time. It's not just the electrical components though. This part was unique in that it required a very specific plastic shroud. We've added a speaker in this case and need to add a speaker grill to our design. SolidWorks has unique plastic tools to aid in this process, further simplifying the design, eliminating the need to create lots of complex features. Here you can see we enter some basic parameters and the speaker grill is complete. There's also mounting bosses and snap hooks as well. Here we might want to add some snap hooks to snap this into the sheet metal cover of the refrigerator design. Like before, you enter some basic parameters and let SolidWorks do all the hard work for you. But once those plastic parts are designed, we need to verify that they're going to be manufacturable. And SolidWorks has a host of tools, including draft analysis to help us find problems, as well as undercut analysis. In this case, we can see there's really no problems except for the snap hook that we've included, but that's an intentional undercut on this design. Finally, we want to see how this part will perform when being plastic injected. SolidWorks Plastics allows you to quickly create a mesh of your plastic part and evaluate different design ideas. For example, where you might want the injection location to be on your design could affect the overall fill. When you're done, you can always evaluate the results to get a better understanding of how your plastic parts will be manufactured. There's a lot of information that can be gathered here that's going to be critical to the success of your design. Finally, we might want to collaborate all of our changes, and eDrawings is a great way to do this. All we need to do is simply say publish an eDrawing and email it off. Once the recipient receives the e-drawing, they can measure and mark up and add comments to this design. Here's that initial interference we saw earlier. In this case, somebody spotted it and they were a little bit concerned about it. They can easily just add a comment to this e-drawing and email it back to me so I can see these changes. Finally, you might want to create some great graphical representations of your design once it's all finished. And PhotoView 360 is a great way to create beautiful renderings of your design. It's very powerful, leverages multiple cores, and can even use multiple computers on the same network. And as the renderings are completed, you can use them to really convey your ideas to others inside and outside of your organization and use them in marketing materials. As you've seen, SolidWorks provides many solutions for bringing your designs from a simple idea to a completely realized manufacturable design. In this case, we took a simple refrigerator and made it web-enabled for the Internet of Things.
With the multiple discipline design capabilities and seamless integration between SolidWorks' portfolio of tools and in integration with third-party products, SolidWorks provides a unified design environment for the IoT device development. With additional and powerful PDM capabilities for data and configuration management, SolidWorks provides a full integrated solution for all aspects of IoT device development and management today. Let's recap SolidWorks IoT design solutions. For ECAD, we partner with SolidWorks Partner Solutions. For ECAD to MCAD, SolidWorks has CircuitWorks. For 3D design, documentation, and system-of-systems design, we utilize SolidWorks Professional, SolidWorks Premium, SolidWorks Schematics, and SolidWorks Electrical 3D. For simulation and testing, SolidWorks Simulation and Flow, and SolidWorks Plastics. And for technical communications, SolidWorks Composer and SolidWorks eDrawings. And for technical data management, we use SolidWorks Enterprise PDM.
All right, thank you, Louis. And let's go into our last couple of poll questions here. There's a typo on this one. So what's your level of interest in the SolidWorks solutions? You're just browsing, beginning your investigation, comparing products, ready to purchase. We'll give you a couple of seconds to complete that. All right. Looks about 80% of you guys are just browsing, which is good. And then we'll hide that, and we'll launch our last question. Would you like any further information from us? I'll give you a couple of seconds to fill that out. All right. We'll close that out. Okay. And with that, thank you guys. Great presentation. We covered a lot. Now, if you have any questions, we'll take them at this point in time. You can just type them in at the bottom, and we'll get back to you. First one, is there any program partner for design PCB compatible with SolidWorks?
Most products are compatible. We use a universal interface that allows us to interface with most partner products. You can either interface with almost everybody out there. We do work with directly with Mentor Graphics, Cadence Design Systems, Altium, Zukin, and all of our partners on this. And we use a IDF interface directly, and we are part of the IDF committee. So CircuitWorks has a direct interface to IDX or IDF to most of these, to most of our third-party solutions.
Okay. Does SolidWorks support design fault analysis, FDMEA?
We'd have to talk with our advanced solutions team, but some of the simulation analysis tools that we have will fall under that particular category. We need a little more specifics to see which areas that we would cover, but we do cover a great deal of area.
Okay. Can SolidWorks export design details, BOM, and tolerance analysis needed for reliability analysis?
Yes, through some of our new tools that we do have out there today. Through the EPDM integration, you can get a bill of materials right of EPDM. It walks through the trees, and with SolidWorks Electrical, we can actually integrate both electrical and mechanical bills of materials, so you come up with one bill of material. And for the other analysis tools, we actually have a new set of tools that we just announced, which is Inspection Expert, which will have the capability of doing some of this analysis work and actually capture your data so you can actually use. Inspection Expert can actually be used by your incoming inspection or your post-inspection departments.
Which tool has configuration management?
Well, all of our tools have different layers of configuration management, but our EPDM tool, our Product Data Manager, has a very in-depth, allows you to do complete configuration management of not just native SolidWorks files, but you can also use Word documents. You can also use, we could actually be able to capture, software that would be running within the device, software that makes the interfaces for the device. So we have a broad range of capabilities of capturing most data that's being used today. Can be captured by our data management system, which we call EPDM,
okay.
Enterprise Data Management.
Are there different versions for CircuitWorks, like a premium, like there is premium?
No, there's only, at this time, there's only one version of CircuitWorks, and it's part of SolidWorks Premium Tool Suite. When you buy SolidWorks Premium, CircuitWorks is part of the tool. Now, everybody has, all versions of SolidWorks have a version of CircuitWorks in them. It allows you to read in certain types of export files out of the boards. They don't give you as much details. They will make block diagrams and not be able to break it down to the very unique component. So you have to have the version that comes with. If you want to get down to the geometries of every chip and every component on the printed circuit board, you need to purchase SolidWorks Premium.
Let's see. What will some of the limitations be for the Internet of Things?
There is no really a limitation. I would say that sky is the limit. The limitation will be your own imagination. As long as you want to have a device who is aware of his environment, capture information, and retrieve it and analyze its information, then put it together into a dashboard application, then it's up to you what you can connect and what kind of devices you want to make smart.
Okay, and our last question, what is unique about SolidWorks compared to other IoT development tools?
We're very cohesive. We have a cohesive development platform, and we're also multi-user and multi-concurrent user, and we also have data management. So we have an end-to-end solution where we fuse the data together into our data streams. So we're one of the only companies out there today that can provide a full solution with integrated data fusing today. We do integrate third-party products such as printed circuit boards, and the firmware and some of the other pieces will be handled by our configuration management tools, but we are completely within the electromechanical interface. We are completely fused, which is a lot different. We offer a complete solution from end to end for all multiple disciplines.
All right, thanks. All right, thanks, guys. That about wraps it up. If we haven't gotten to your question, we'll be sure to do that by email. And I thank you for your time on our webinar, and we look forward to seeing you on our next one. Thank you.